Hey 7th grade. The goal of this next video in our unit over the study of linear functions is to discuss a different way of writing linear equations, one that does not look exactly the same as slope-intercept form. So as a review from the last video, we know that you can write an equation in slope-intercept form if you know two things, one being the slope and the other being the y-intercept. There's a problem with this though. What if you don't know the y-intercept of the line? Okay, what if you just are given two random points on the line and you don't know where that line is actually crossing the y-axis? Well, we have another form for linear equations for when such a problem occurs, and that is what we refer to as point-slope form. Okay, so point-slope form is actually going to be another form that we can use when we're dealing with linear equations here. It's still a linear equation, it's just going to look a little bit different than what your slope-intercept form looked like. We're actually going to be studying a total of 3 different forms for linear equations in this unit. We did the first one already, that was your slope-intercept form, y equals mx plus b, so this form will be number 2. Point-slope form of a linear equation looks like this. Y minus y sub 1 equals m times the quantity x minus x sub 1. So you'll notice a couple of similarities to slope-intercept form. You notice there's a y on the left side of the equation and x on the right side of the equation, and the big thing is there's that m value there. Okay, so m, just like slope-intercept form, and anytime you see an m in this unit, in fact, m is still going to stand for your slope. Okay, but this time we have not a b value, but an x sub 1 and a y sub 1 value. Okay, and so what those values stand for are actually the coordinates of not necessarily the y-intercept, but just some random point on the line. Okay, and so that's where we get this down here, this x sub 1, y sub 1. So the x sub 1 is referring to the x-coordinate of some point on a line, and then the y sub 1 is referring to the y-coordinate, again, of some point on that line. So what we're going to do in the first couple of examples here is we're going to practice using this point-slope form, and then we're going to actually do some graphing as well with it. So going to the first couple of examples, we're going to practice writing equations in point-slope form. When you're writing an equation in point-slope form, you still have to know two things. You need to know the slope, but you don't need to know necessarily the y-intercept. You just need to know a point on the line. Okay, it can be any point on the line, but you also need to know that and the slope. So in each of these examples, that's what I've given you. I've given you a point on the line, that's not the y-intercept, and I've given you the slope. So for number 1, we have -3, 6 as the point, and the slope is -5. So I'm going to write this form down so I can practice committing it to memory. Y minus y sub 1 equals m times the quantity x minus x sub 1. And now I'm going to plug in 3 different things. The first thing I'm going to plug in is this y sub 1 coordinate. So I'm going to go ahead and put a placeholder in there, just like I did for my slope formula, so I don't mess up my signs. The second thing I'm going to plug in is my m value, so I'm putting a placeholder in for that. And then the last thing I'm going to plug in is this x sub 1 value, so I'll put a placeholder in for that. So where I put these 3 boxes in, that's what you're going to be plugging in to this form here. Everything else is going to stay the same. So let's start with the slope. We know that the slope is -5, so this -5 is going to come right down here and get plugged in for that m value, right in front of those parentheses. Okay, then we have the x-coordinate of our point. The x-coordinate is -3. So it's going to come down here to the very end of my equation and go in where this x sub 1 was. Okay, right after the subtraction sign. And then the y-coordinate, which is +6, is going to come down on the left side of the equation and go in where the y sub 1 was. The reason I'm using those placeholders is not necessarily for the m value, but if you notice, we have subtraction signs in our formula, in our point-slope form, so this is very similar to the slope formula. You're going to have to be very careful of sign changes when you're plugging in your x and your y coordinates, because notice when we're plugging in a positive for our y-coordinate, in this case +6, this left side of this equation, if we simplify it, becomes y minus 6. Okay, however, when we plug in a negative coordinate, okay, so we have a -3 for our x coordinate over here. When we simplify what's in parentheses, that's going to become x plus 3 because we have a minus negative here. So we're going to get an x plus 3 in parentheses, and then our slope is going to stay just a -5. So we get, for our point slope form for this problem, the equation y minus 6 equals -5 times the quantity x plus 3. Okay, we're going to see something similar in number 2. This time I've given you the point 8, -4, and a slope of 2/3. So we're going to take this point slope form, y minus y sub 1 equals m times the quantity x minus x sub 1, and we're going to plug in those three values: the slope, the x coordinate of the point, and the y coordinate of the point. Okay, so the slope of this one is 2/3. So that's going to come down here. The x coordinate of this line is +8, so that's going to come down here after the x minus. And then the y coordinate is -4, and that's going to come down here after the y minus. And so when you simplify this, you get y plus 4, because it's a y minus -4, equals +2/3 times the quantity x minus 8. So here's the thing I want you to notice every time we use our point slope form. Whatever your signs are in the point that I give you, in this case I gave you a +8, -4, those signs are going to change when you actually write your equation. Okay, your x coordinate, +8, becomes an x minus 8 in the equation. Your y coordinate of -4 becomes a y plus 4 in the equation. Okay, so those signs actually change. Your slope sign, however, does not change. If we have a +2/3 for our slope, then in the equation you're also going to see a +2/3. Okay, so that's just some practice writing equations in point slope form. Now we're going to practice graphing some here in examples 3 and 4. So this process is basically going to be the same as what we did with slope-intercept form. The only difference is, instead of giving you the y-intercept, I'm just giving you a point on the line. So for number 3 here, we have the equation y minus 1 equals 2/3 times the quantity x minus 2. So let's practice identifying which point I gave you based on this equation. Okay, the point I gave you would have an x coordinate of +2, and that's based on the fact that you have an x minus 2 here in your equation. I just told you that the signs are going to be the opposite anytime you're going from the equation to the actual point. So that means you have a +2 for the x coordinate. You have a y minus 1 in your equation, so that means the y coordinate of your point is going to be a +1. So again, the signs of each of your coordinates in your point are going to be opposite of what you see in the equation. Your slope, however, is not going to change signs. Okay, so the slope of this line is going to be a +2/3, just like what we see right here. Okay, so now that we know this point and this slope, we're going to start out graphing this with our point. Okay, our point is 2, 1, so I'm going to plot the point 2, 1, which, if we start at our origin, is right 2 and 1 up from the origin. So whenever we're graphing a line, we always start with the point. Okay, then we're going to keep our pencil on that point, and we're going to, from there, do our slope. Our slope is +2/3, so that means we have a rise of +2 and a run of +3. So from this point, we're going to go up 2 spaces and right 3 spaces, and follow that pattern. And then when we run out of room, we'll go back to this point 2, 1. We can also go down 2 spaces and left 3. We want to keep in mind that we have a positive slope, and so our line at the end should be a line that is increasing, which it looks like it is. And so now we'll just go ahead and we'll connect our dots. And so this is the line that has a slope of +2/3 that is also passing through the point 2, 1. Okay, for number 4 here, we have y minus 5 equals -4/5 times the quantity x plus 2. So the first thing I'm going to do is identify the point that this line is going through. Okay, so we're going to take the opposite of this x value we see. We see an x plus 2, so that means we have a negative 2 for our x coordinate. And then we take the opposite of this y that we see. We have a negative 5 here. So that means that our y coordinate is going to be a positive 5. So we're going to start out at the point negative 2, positive 5, which is going to be left 2 and up 5 from the origin. Okay, so right there. Our slope for this line is negative 4/5. So again, I can treat that as negative 4 over positive 5 or positive 4 over negative 5. And so if I go to my point negative 2, 5, that means I can either go down 4 and right 5. And I'll follow that pattern. Down 4 and right 5. Or I can go back and I can go up 4 and left 5. And that will give me a line with negative slope. It is decreasing. That passes through the point negative 2, 5. Okay, finally, I want to talk about, again, how to write an equation in point-slope form if you're given either a graph or only 2 points. So for number 5 here, I'm giving you a graph of an equation, and I want you to write the equation in point-slope form. Again, you need 2 things to write an equation in point-slope form. You need a point, okay, just 1 point on the line. You also need the slope. Okay, well, on this graph, I've actually labeled 2 points. I've labeled negative 3, 6, and 6, negative 6. So you're actually able to pick either of these points as your point to use in your equation. Okay, you can pick either negative 3, 6, or 6, negative 6. I'm just going to go ahead and take this top point up here, negative 3, 6. So that's going to be the point I'm using. The slope should be the same for everyone, though. So I'm going to calculate the rise over the run from this point to this point here. And so if I start with my top point, that means I need to go downwards. So that's going to be a negative rise. Let's see how many spaces I'm going down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 spaces. So I have a negative 12 as my rise. And then my run, I'm going to need to move to the right. That's going to be a positive direction. 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces is what I'm moving for my run. So your slope is a negative 12 over positive 9, which reduces to negative 4/3. So that means that the point-slope form of this line is going to be the equation. Again, we're using y minus y sub 1 equals m times the quantity x minus x sub 1. So it will become y minus our y coordinate that we're using is a positive 6. So it'll be a minus 6 equals negative 4/3 times the quantity x. Since we have a negative 3 up here, it will be a plus 3 here. So y minus 6 equals negative 4/3 times the quantity x plus 3. I mentioned that you don't have to choose the point negative 3, 6. You could also choose the point 6, negative 6 to be your point that you use in your equation. So when you do your homework, some of you are going to choose probably one of those points and others would choose the other point. So let me show you what the other possibility for this would look like. If we chose the point 6, negative 6 instead, then we would still plug in a negative 4/3 for our m value. But for our y sub 1 value, this would become a y plus 6 because of this negative 6 up here equals negative 4/3 times the quantity x, and then since this x coordinate is a positive 6, we'd have a minus 6 here. So that's the other possibility for your equation here. Whenever you're writing equations in point-slope form, a lot of times your answer is going to look different from your neighbor's based on which point you choose to plug in. Okay, finally, in number 6, we're going to be doing the same thing, except this time I didn't give you the graph, I just gave you 2 points on the line, 3, negative 1, and negative 7, negative 4. Well, we know from the first video that even if you don't have a graph, you can still calculate the slope between 2 points using your slope formula. So that's what I'm going to do for this one. I'm going to use my slope formula, m equals change in y over change in x, and I'm going to find the slope between these 2 points. Okay, so my y coordinates are negative 1 and negative 4, and my x-coordinates are positive 3 and negative 7. So my slope for this line will be negative 1 minus negative 4, that becomes plus 4, so you get positive 3, divided by 3 minus negative 7, that becomes 3 plus 7, so you get positive 10. So your slope for this line would be 3/10. Okay, so now you're going to take your point slope form, y minus y sub 1 equals m times the quantity x minus x sub 1, and you have two options. You can either choose the point 3, negative 1 to write your equation, or you can choose the point negative 7, negative 4 to write the equation. If we choose the point 3, negative 1, this is what we get. We'll get a y plus 1 equals 3/10, our slope, times the quantity x minus 3. Again, a different sign on the 1 and the 3 when we plug in. Or, if we choose the point negative 7, negative 4, we would get this. Y plus 4 equals 3/10 times the quantity x plus 7. When you're doing problems on your homework and your test, you do not have to write both forms. You can either write the equation using this point 3, negative 1, or this point negative 7, negative 4, but you don't have to write both equations. Just one is fine. Okay, as always, if you have any questions over what we talked about in this video, feel free to write those down or shoot me an email containing those questions, and I'll try to address those in class. Until I see you again, have a nice day. You're all wonderful people. Take care.